problems to work on. Let's go through what you have done and see how you did. So the first one here is addition. Remember, when we add, we have to have the same name. So we have to have common denominator. So we are going to rewrite these with a common denominator. What's the common denominator between 4 and 8?
8.
8. So we're going to keep it at 8. So the 7/8 doesn't change. 3/4, well, 4 times 2 is 8, so 3 times 2 is 6/8. 6/8 plus 7/8 is 13/8. That's improper, so we're going to split it into a mixed number. That's 1 and 5/8. So we keep the 5/8 and we carry the 1. 1 and 7 and 8 plus 4 is 12. So 12 and 5/8. Any questions on that problem? Okay, number 2. I don't know why I labeled it 8, 9, 10. I must have been thinking about something else. Let's go 2, 3, and 4. There aren't 6 problems missing there anywhere. Sometimes it's going to be one of those days, huh? So 8 1/3, 2 3/5. We need a common denominator, which will be
15.
15. Good. So 3 times 5 makes 15, so 1 times 5 would be 5. 5 times 3 to be 15, so 3 times 3 is 9. And now we are subtracting. 5 minus 9, however, can't be done, so we borrow from the 8. This is a 7. What do we have to do to the 5?
Add it.
Add 15 to it, right? There's no 20 15ths. When we borrowed 1, what we're borrowing is one whole object, but that denominator tells us that it contains 15 pieces. Now we can look at 20 15ths minus 9 15ths is 11 15ths. And 7 minus 2 is 5. So we're at 5 and 11 15ths. Okay, number 3. Now, I showed you the process for multiplying mixed numbers, but it's kind of complex. So we're going to stick with turning them into improper fractions. So 2 and 1/4.
Could be math.
It doesn't say you can have a microphone.
Oh, I just joined math.
2 times 4 is 8, plus 1 is 9. So 3 and 5, 6. How many 6ths is that going to be?
18.
23.
3 times 6 is 18, plus 5 is 23. You were both kind of right there. So now we multiply. There's nothing we can cross cancel, so we're going to multiply straight across. 9 times 23 is 207. 4 times 5 is 20. So 207 divided by 20 is 10 with 7 left over. 10 and 7 20ths.
7/20.
Perfect. Any questions on that one?
Yeah, it should be 6.
What is it?
Should be 20.
Thank you. That's like I said, sometimes you know it's going to be one of those days from the start. Let's try that again. We'll back up here. This should be 6, not 5ths. This was a 6 here. 23 over 6. So that should be 4 times 6 is 24. So it's 207 over 24. So 207 divided by 24. 24 does not go into 2, so leave it blank above the 2. Does not go into 0, we'll leave it blank above the 0. Into 207, 24 goes in there, was it 8 times? Let's try that. 8 times 4 is 32, so 2 carries the 3. 8 times 2 is 16, plus 3 is 19. So we got 15 left over. So that is 8 and 15 24ths, but of course we see we can do what with that?
5 by 3.
Divide by 3. That's 8 and 5/8.
5/8.
If I had done it right the first time, I probably would have caught that you could have cross-canceled. The 9 and 6 both could have been divided by 3. That would have simplified that for us a little bit. Okay. Any questions on that one now that I got it right? Number 4, division of fractions. Well, again, we looked at how you can actually divide fractions, but then we realized that, or we looked at the way most of us were taught is that shortcut of taking a reciprocal and multiplying. So if we're going to multiply, it makes sense we start out with the same step we do with multiplication, and that is to turn them into improper fractions. 4 1/2 becomes how many halves?
9 halves.
Good. 4 times 2 is 8, plus 1 is 9. 1 2/3 becomes how many thirds?
5 thirds.
5 thirds. Good. Now it's really tempting to cross cancel here, but this is division. We can only cross cancel after it's been changed into multiplication. Well, dividing by 5 thirds, the division operates on the number that comes after it, becomes multiplying by the reciprocal of 3/5. Now we could cross cancel, but nothing here does cancel out. So 9 times 3 is 27. 2 times 5 is 10. So again, 27 divided by 10. 10 goes into 27 twice with 7 left over. So 2 and 7, 10. Any questions there?
No.
Okay. Now, quiz 2 is sitting out there. It is posted for you guys to work on today. I'm going to actually end class a little bit early, so you have time to get to a computer and work on quiz 2. As I mentioned, I changed it up a little bit for you so that it'll be easier to manage papers, so I don't have papers coming in from 8 different classes. Just kind of show you how that's going to work. Rather than emailing it to me, when you go into Blackboard, forget here. Okay, this is your class. You go still in course information, and it'll be week 2 because that's where we're at. But you'll see quiz 2 is up here. If you just click on this link, it'll download the quiz for you. But if you just click on the bold quiz 2, it'll take you here. Here you can still download the quiz. Right there, you got the link to the quiz. But then when you're finished with it, you can hit browse my computer here and upload it just like an attachment. Or if you'd rather just type in the answers, you can come down here and type in the answers that you have down here and submit them that way. That'll be a lot easier for me to give feedback. Once it's submitted, then it'll actually allow me to put little Post-it notes on your quiz to send it back to you so you know where you got them wrong. The corrections will still have to come through email, but this will make it a lot easier to keep track of the initial quizzes at least. So for quiz 2, make sure you're submitting it there by clicking on the bold quiz 2 and week 2 folder and either uploading it or typing it in or copying and pasting it to this window. Okay, let me get out of here. So this brings us to the next section, the next type of number that we want to learn about, and that is decimals. Decimals, again, depend heavily on that concept of place value. We talked last week about starting at that decimal point and working our way backwards to the left. Well, this is the ones place, the tens place, the hundreds place, the 1,000s, the 10,000s, and continuing on. And I purposely wrote them out as numbers here so that you can see the pattern. As we move one spot to the right, the numerical value is divided by 10. 10,000 divided by 10 is 1,000. 1,000 divided by 10 is 100. 100 divided by 10 is 2, and so on down the line. Or sorry, 100 divided by 10 is 10. 10 divided by 10 is 1. And so if we continue past our decimal point, that pattern has to continue. 1 divided by 10 is 1/10. 1/10 divided by 10 is 1/100. 100th divided by 10 is 1/1000th. And 1/10,000th. And that pattern would keep going on down. I get asked a lot why there is a ones place on the left of the decimal and not a once place on the right side. Well, this is why. It's because of that continuation of that pattern. Technically, these place values are powers or exponents, where this is actually 10 to the power of 1 is 10, 10 squared is 100, 10 to the 0 is technically 1. This is the power of 10 to the negative 1 and on down the line. Well, there is no negative 0, so that's why there isn't that once place on the other side of the decimal point. Now, you might be looking at these place values thinking they look an awful lot like fractions, and that's because they are. Decimals are nothing more than fractions with specific denominators. In this case, denominators that are powers of 10. It's just a shortcut way of writing a fraction. 0.7 really is just 7/10. It's just a short way of writing it. Or 0.398 is again 398. The last digit is in the thousandths place. That's the denominator of that fraction, 398 thousandths. Or if we had 5.125, the part in front of the decimal point is the whole number portion of the mixed number. This is often referred to as a mixed decimal. Some textbooks even refer to decimals as decimal fractions, meaning fractions with decimal denominators or powers of 10. So with this, the 5, the whole number, stays a whole number. It's the part that's after the decimal point that becomes the fraction, 125 thousandths. Now we're going to look more at converting from decimal to fraction as time goes on. There's actually a couple of different ways of converting from decimals to fractions, depending on what your purpose is. Whether you want to find the exact fraction, or in your case, many times you're looking for a tool size or a bolt size or whatever. You have to round that to the nearest 8th or 16th or whatever increments you're working with for that equipment. So let's review our rules for addition and subtraction. When we add or subtract, we must have the same name. For decimals, that means lining up the decimal point. Making sure that we're only combining digits that have the same place value. We combine the counts. Well, that's going to mean the same thing in decimals as it does for any whole number. You just combine the counts that are in the same place value. And we keep the same name. For decimals, again, that's going to mean drop the decimal point. Straight down. So let's look at some examples of this. 0.483 plus 0.39. Now, as we said, we have to keep the decimal points lined up. So I write my first number, then I put my decimal point for the second number right below it, so I make sure it lines up. Now, these don't have the same number of decimal places. That top number is 483 thousandths, the bottom number is 39 hundredths. So we should fill in that missing place value with a 0 to make sure these are both dealing with thousandths, making sure they both have the same name. Now we add 3 and 0 is just 3. 8 and 9 is 17. We're going to keep the 7 and carry the 1. 1 and 4 is 5, plus 3 is 8. Then we drop the decimal point straight down. So 0.873 is that result. Dropping that decimal point straight down is keeping that name of thousandths. Something like this, 7.648 plus 15.89. Again, we have to line up the decimal point. So again, I drop the decimal point down, and I work my way out from the decimal point to make sure things stay lined up. Put a 0 in here to make sure I fill in that missing decimal place again. And then we'll go ahead and add. 8 and 0, of course, is just 8. 4 and 9 is 13, so I'm going to keep the 3 and carry the 1. 1 and 6 is 7. 7 plus 8 is 15. So I keep the 5 and carry the 1. Notice the decimal point does not affect that carrying at all. But before I do the next column, I do have to bring the decimal point straight down. Now 1 and 7 is 8 plus 5 is 13. So 3, carry the 1. And 1 and 1 is 2. Any questions on that? Subtraction. $7.643 minus 2.59. Again, we line up the decimal point. Now with subtraction, again, we really should fill in any missing decimal places with zeros. And then we'll subtract. 3 minus 0, of course, is just 3. 4 minus 9 can't be done, so we're going to borrow from this 6 to make it a 5. This is now a 14. 14 minus 9 is 5. 5 minus 5 is 0. And now we have to bring that decimal point straight down before we go across it. 7 minus 2 is 5. The example I want to make sure I show you is one that looks like this. 32 minus 9.6437. When I go to set that up, of course, the 32 doesn't have a decimal point written, but it's there. If it's not written, it's presumed to be at the end of the number. So that's what I have to make sure I line up with this decimal point when I write the second number. 9.6437. Now here we don't have a choice. We have to fill in those missing decimal places with zeros so that we can work with them. Now we go to subtract. 0 minus 7 can't be done, so we have to borrow. But we go to this next place here. There's nothing there to borrow from. It's just a 0. So we have to go all the way over to this 2 here to find something to borrow from. We borrow from that 2, it becomes a 1, and this becomes a 10. When you borrow, it only goes 1 digit over. But we still need to get it all the way down here. So that means we're going to have to keep borrowing. Borrow from that 10, it's a 9. Now this is a 10. And we repeat it. Borrow from that 10, it's a 9, and now this is a 10. And we borrow one more time. That's a 9, and this is a 10. Some of you may have been taught to just do you borrow and just go 9, 9, 9, 10. That's just that repeated borrowing in action. Now we're ready to subtract. 10 minus 7 is 3. 9 minus 3 is 6. 9 minus 4 is 5. 9 minus 6 is 3. Now before we cross the decimal point, we have to bring it straight down. 1 minus 9 can't be done, so we're going to borrow. This will be a 2, and this is an 11. 11 minus 9 is 2, and 2 minus nothing is 2. Oops. Yeah, so there we go. We got 22.3563. Any questions on problems like that? Okay, so next is multiplication and division. Remember, when we multiply or divide, first of all, we do not need the same name. For decimals, that means no need to line up the decimal point. We're going to combine the counts. Now remember, because we don't need the same name, that means every digit in one number can combine with every digit in the other number. There's a lot more steps to the multiplication and division. Third, we're going to also combine the names. That takes on a couple forms. In multiplication, that's counting decimal places. In division, that means moving the decimal point the appropriate distance. Now again, that's a shortcut, and we'll show you how it works in a little bit. So for multiplication, now if we actually wrote out our numbers in long form, we wouldn't need a shortcut. If I had 0.02 times 0.3, I could just say that this is 2/100 times 3/10. I could multiply out the counts. 2 times 3 is 6, but also multiply the names. Hundredths times tenths is thousandths. So when I do it that way, this is pretty obvious. This is 0.006. But it is kind of clunky and clumsy to write out all the numbers in their long form with their place values written in there. And it gets kind of confusing to do the multiplication with all that mess in there. So the shortcut we have learned is to just multiply the numbers, totally ignoring the decimal points, and then count the number of decimal places in the problem. Here there's 1, 2, 3 total decimal places in the problem. So in our answer, we have to put 1, 2, 3 total decimal places. So if I have 2.48 times 3.7, first of all, I do not have to worry about lining up that decimal point. I am going to multiply ignoring the decimal points completely. So just like whole numbers, I start with that last digit of the bottom number, the 7, and I combine it with the last digit of the top number. 7 times 8 is 56. So I keep the 6 and carry the 5. Now I move over to the next digit of the top number, 7 times 4. Well, 7 times 4 is 28, but I have to add the 5 I carried, that's 33, so I keep the 3 and carry the 3. Moving over to the next digit on top, 7 times 2. Well, 7 times 2 is 14, plus the 3 is 17. So 7, there's no place to carry the 1, so I just move it over to the next place value. Now again, when we move over to the next digit of the bottom number, we've been taught we have to put a 0 in down here. I also put a line up above here. The reason I put that line in there is so I know that anything below that line is an old carry. I don't try to use it again. Now I'm going to go back to this 3. 3 times 8 is 24, so that's 4. Carry the 2. I put that new carry above the line, so I know it's new. Then I do 3 times 4 is 12, plus 2 is 14, so 4. Carry the 1. And 3 times 2 is 6, plus the 1 I carried is 7. Now I move down. I'm just going to add the things that are lined up. So 6 and 0 is 6. 3 and 4 is 7. 7 and 4 is 11. So again, I can't have 2 digits there, so I keep the 1 and carry the 1. 1 and 1 is 2, so 7 is 9. Now I have to locate the decimal point in my answer. Well, there's 1, 2, 3 total decimal places in my problem again. So I start at the end of the number and I count 1, 2, 3 total decimal places in my answer, giving me 9.176. Now last week I made a big deal about estimating, and I'm going to stomp on it again here just a little bit. If I take an estimate here, 2.48, that's about 2. 3.7, that's about 4. 2 times 4 would be 8. I'm expecting my answer to be about 8. So that's the only place I can put that decimal point that makes any sense. 91.76 would not make any sense, and 0.9176 would not make any sense. 9.176 is the only decimal point location that makes any sense in that answer. Page here. So at 6.435 times 12.8. Now this is going to be a longer problem. Again, we do not have to line up the decimal points. And once we have the problem written out, we completely ignore the decimal points up until the very end. So I start with the last digit of the bottom number, combined with the last digit of the top number. 8 times 5 is 40. So I'm going to keep the 0 and carry the 4. Now I move over 8 times 3. 8 times 3 is 24, plus the 4 I carried is 28. So I keep the 8 and I carry the 2. Moving over again, 8 times 4. 8 times 3 is 24, plus the 4 I carried is 28. So I keep the 8 and I carry the 2. Moving over again, 8 times 4. 8 times 3 is 24, plus the 4 I carried is 28. So I keep the 8 and I carry the 2. Moving over again, 8 times 4. 8 times 3 is 24, plus the 4 I carried is 28. So I keep the 8 and I carry the 2. Moving over again, 8 times 4. 8 times 3 is 24, plus the 4 I carried is 28. So I keep the 8 and I carry the 2. Moving over again, 8 times 4. 8 times 3 is 24, plus the 4 I carried is 28. So I keep the 8 and I carry the 2. Moving over again, 8 times 4. 8 times 3 is 24, plus the 4 I carried is 28. So I keep the 8 and I carry the 2. Moving over again, 8 times 4. 8 times 3 is 24, plus the 4 I carried is 28. So 8 times 4 is 32, plus the 2 we carried is 34. So that's 4, carry the 3. And 8 times 6 is next. 8 times 6 is 48, plus 3 is 51. So 1, we would carry the 5, but there's no place to carry it to, so we just move it over to the next digit, next place value. Now again, we move over, we're going to move over to the next number in that bottom row, the 2, but when I do that, I have to fill in a 0 down here. I'm also going to put a line up here, so I know that those are old carries. 2 times 5 is 10, so that's 0, carry the 1. 2 times 3 is 6, plus the 1 is 7. 2 times 4 is 8. There's nothing above the lines. There's nothing carried to add to it, so that's just 8. And 2 times 6 is 12, so 2. No place to carry the 1, so we'll just move it over. Now again, we're moving over one more digit on bottom. Now we've gone over 2 digits from the beginning. Technically, when we put this 0 in down here, what we're really doing is we put a 0 in for every digit that's to the right of it. So this 1 has 2 digits to the right of it, so I have to put in 2 zeros down here. We'll make sure we do that. We'll put a line up here for my carries as well. Excuse me. 1 times 5 is 5. 1 times 3 is 3. Nothing was carried. 1 times 4 is 4. And 1 times 2. So I've got the zeros here. That's just 0. 8 plus zeros is still just 0. 4 and 7 is 11, plus 5 is 16. That's 16, carry the 1. 1 and 1 is 2, plus 8 is 10, plus 3 is 13, so that's 3, carry the 1. 1 and 5 is 6, plus 2 is 8, plus 4 is 12, so again, 2, carry the 1. 1 and 1 is 2, plus 6 is 8. Now, I get asked all the time, do I need this 0 at the end here? Since it's going to be after the decimal point, it doesn't mean anything. And the answer to that question is, in the end, no, but for right now, yes, we have to keep it there because it is one of the decimal points. When we're counting decimal places to locate our decimal point in the answer, we need to count that one, even though it's a 0. So in the problem, we had 1, 2, 3, 4 total decimal places. Might be easier to count them over here because I don't have it all cluttered up. So in my answer, I have to count that 0 as my first decimal place. 1, 2, 3, 4. My decimal point goes right there, 82.3680. Now I can drop that decimal point because mathematically it doesn't mean anything here in most calculations. In a few weeks, we're going to talk about measurement, and we're going to talk about the importance of that 0 at the end of the number if it's a measurement. It actually tells us something if it's part of a measurement. Now again, we could use estimation here. This is 6.4, well that's about 6. 12.8, that's about 13. 6 times 13 is about 78. 82 is the only decimal placing that makes any sense there. 8.2368 would not make sense. 823.68 would not make any sense. So it's always useful to go back and double check to make sure your decimal placing makes sense. A warning on your calculator, the decimal point statistically is one of the first keys to start getting sticky, to start wearing out. It's because it doesn't get used as much. It gets used a lot in short bursts and then not much at all for a long time. So be very careful when you're entering these. 6.435 times 12.8. If I missed one of those decimal points and it didn't register, I'm going to get the exact same digits. The decimal point's just going to be slid over. It might be 823 instead of 82. So again, that estimation is very important to have that estimate of what you think the answer is going to be in your head before we start to calculate. Just to let you guys know, normally what I would do is I would give you guys some homework with 5 or 10 minutes left here in the first hour and give you some time to work and then take a break. If you guys are okay with skipping break, because I'm planning on giving you some time at the end to work on the quiz, letting you go early, in other words, I probably only have about 20 or 25 minutes worth of material left, if that. Are you guys okay with me just going through and skipping break?
Yeah.
If anybody needs a break, feel free to get up and use the restroom if you need to. But let's just keep on going through that and finish this off. Okay, so the next step is division. And division, we said, is that one operation that has been twisted the absolute most. Really kind of ugly to the point where you don't even recognize it. So let's say I have something like 10.741 divided by 2.3. Now, realistically here, if we go back to that process we saw on the first day of repeated subtraction, there's no need to modify this at all. I can look at this first place value here. This is the tens place. I can do 10 times 2.3 is 23. That's too big. If I go to the next place, the ones place, 1 times 2.3 is 2.3. I can subtract that. In fact, I can subtract that 4 times. 2.3 times 4 is 9.2. I can subtract that from what's there. Now, by the way, I'm not going to force you to do it this way. I'll show you the shortcut we're all familiar with in a little bit. But we subtract here, we get 1.5401. We have to make sure that what's left here is smaller than the initial calculation here, the 2.3. So what we just did there is we subtracted a bundle of 2.3s 4 times. So 1 times 4 is 4. Well, since this is a decimal, we can keep going to the next place value, which is the tenths, the 0.1 place value. 0.1 times 2.3 is 0.23. I can subtract that from what's left. Looks like I can do it 6 times. So what's that? 18, 13, 1.38. So I subtract. I've got 0.16 left there, or 0.161 left. Which again is smaller than the 0.23. So again, what I just did there is I subtracted a bundle of 0.1 and I did it 6 times. So that multiplies out to be 0.6 that 0.6 times I just subtracted the 2.3. Then I go to the next place value, which would be the hundredths. 0.01 times 2.3 is 0.023. And I can subtract that. It looks like, can I do it 7 times? It looks like I can. 1, carry the 2, 14.161 is exact. So I just had hundredths, or 0.01 times, 0.01 times 7, 0.07, that adds up to 4.67. So you can see it's the exact same process as what I showed you on day 1 with the dividing whole numbers, except we don't like having to go through all of this of writing this all out and writing this out up here in the solution part of it. It gets pretty long. So we shortened it. And the way we shortened it was we decided we didn't want to divide by decimals. We're going to get rid of the decimal and divide. So what we did was we move it over and just say we're going to just take this as, instead of dividing by 2.3, I'm going to move that decimal over. I'm going to divide by 23. Well, I'm going to move this decimal over 1 to cancel it out. So it's 107.41 divided by 23. Why am I able to do that? Well, fractions and division problems are interchangeable. This problem right here is the same as saying 10.741 over 2.3. And we've seen in a fraction, I can multiply both the top and bottom by the same thing, and it doesn't change the value of the fraction. Well, if I want to get rid of this decimal place down here, I multiply that bottom by 10 to make it a 23. So I multiply the top by 10 as well to make it 107.41. So this problem is equivalent, the 107.41 divided by 23, is equivalent to that original problem of 10.741 divided by 2.3. And now we can go ahead and divide like we did with our shortcut on day 1. 23 does not go into 1. 23 does not go into 10. 23 goes into 107 4 times. 4 times 23 is 92. I subtract, I've got 5, borrow here, that's a 1, a 10, that's a 1, I have 15 left. Notice that's exactly what I did over here. I just left out the extra places, the zeros here. Now I bring down my next place, but since I'm crossing the decimal point here before I can bring down that next digit, I have to move my decimal point straight up. Now I can bring down that next digit, which is the 4. 23 goes into 154. 6 times, I believe. 6 times 3 is 18. 8 carry the 1. 6 times 2 is 12. Plus 1 is 13. And we subtract. This becomes a 4. This will be a 14. That's 6 and 1. Now I bring down the last digit, which is the 1. And 23 goes into 161 exactly 7 times. 7 times 23 is 161. So, this shortcut is what we're used to seeing. It eliminates all this stuff on the side over here and this piece up top in our solution area. To me, it makes a lot more sense to see it this way. But what we did over here, moving that decimal point over 1 spot, was combining the names when we divide. Because we're dividing by 2.3 instead of 23, moving that decimal point over is how we combine the name. So let's say I ask you to do $72.843. Let's go 8435 divided by 0.32. And I ask you to do it to the nearest thousandth. So first, we're going to move our decimal point. So we're not dividing by a decimal. Now this has 2 places. That means if we're in that fraction form, we'd be multiplying by 100 to move it over 2 spots. Well, here we're lucky we just move it over 2 spots. So instead of 0.32, that becomes 32. However, if we move it over 2 spots there, we're multiplying by 100 there. We have to do the same, this other number. That becomes 7,284.35. Now we're going to start to divide. 32 does not go into 7, so we'll leave it blank above the 7. 32 into 72 is going to go twice. 2 times 32 is 64. So we subtract, we're going to borrow from the 7. That'll be a 6. This will be a 12. That is 8. So we'll bring down that next digit. That's 8. 32 goes into 88. Well, I think that's still twice. 2 times 32 is 64. We subtract to get 24. So yes, it is still just twice. Whenever we subtract at each step, what we get here after we subtract, so here we had 8, here we had 24, has to be smaller than what we're dividing by. If what we have left after we subtract is larger than what we're dividing by, then we have to go back and change the number up here. So that 24 is smaller than the 32, so now we'll bring down the next digit, the 4. 32 into 244 goes 7 times. 7 times 2 is 14, so 4 carry the 1. 7 times 3 is 21, plus 1 is 2, 22. What we have left here when we subtract is 20. Now, before we bring down the next digit, we're crossing the decimal point, so we have to move that decimal point straight up into our answer. Now we can bring down the 3. Notice we don't bring the decimal point down. We ignore that in our calculations, just like we did in multiplication. So 32 into 203, I'm going to say 6 times. 6 times 32 is 192. So we subtract there, we have 11 left over. And we'll bring down the next digit, which is a 5. I'm going to make this smaller just so we can see the whole problem on one page here. Well, 32 into 115, it's going to go 3 times. Well, 3 times 32 is 96. So we subtract there, we have 19 left over. Now, we're out of digits up here. There's no more digits here in their number we're dividing by. Nothing left to bring down. But I said I wanted this to the nearest thousandth. And since there is still a remainder down here, with a decimal, we can keep going. I can add a 0 here. That it's after the decimal point, so it doesn't change the value of anything. 0.35 and 0.350 have the same value. Now I can drop that 0 down. 32 into 190. Fortunately, I think that only goes 5 times. 5 times 32 is 160. There's 30 left over. Now that 30 is still smaller than the 32. Now we're at the thousands place. So the big question is, can we stop here? Well, not quite yet. We have to add one more 0 and bring it down. So this is now 300 divided by 32. That's going to go in there 9 times. 9 times 32 is going to be 288. 12 left over. Well, why did we have to go that extra digit? Because we asked for the answer to the nearest thousandth, which means what we're doing is rounding the answer to the nearest thousandth. To round to a certain place value, we have to know the digit that's in the next place value. So that 9 is telling us that that rounds up to a 6. So it's not 227.635. It's going to be 227.636. We have to know that extra digit beyond where we want to round to know whether to round up or down. Any questions there? Now again, when you look at this, it's going to be a little harder to round, to estimate. 72 divided by 0.3, well, 72 is 73 even, whatever. Well, 0.3 rounds to 0, really, so it's going to be a lot tougher to do that estimate with them. So this is one where you just have to be careful. Double check on the calculator. Now, you know, if it was 72 divided by 1, that would just be 72. If the number we're dividing by here gets smaller, the result has to get bigger. So since this is smaller than 1, you know our result here has to be larger than the original number, than the 72. And it does get larger. I want to talk a little bit about estimating with our decimals here. For addition and subtraction, it's not a big deal. You just have to make sure the decimal points are lined up. If I am going to estimate like 0.008 plus 0.05, I cannot combine the 5 and the 8 because they're in different place values. When I estimate those, I just keep the digits in their given place value. There are no two digits in the same place value. There's nothing to add. So 0.008 plus 0.05 is just 0.058. Now subtraction is a lot more, well, let's do one more addition problem where they are in the same spot. 0.003 plus 0.006. Those are in the same spot. They're both in that thousands place, or the third decimal place, if you will. So I can add those values. 3 plus 6 is 9, and it stays in that third decimal place. Now where it's a little confusing is if it adds up to more than 10, more than 9, so that it carries 0.08 and 0.05. The 8 and the 5 are in the same place value, so I can combine them, but 5 plus 8 is 13. But when I combine them, it is the last digit that stays in that place value. So that 13 is in the second place value, second decimal place, or the hundredths place. So that's 0.13. If you think about it, 8 hundredths and 5 hundredths make 13 hundredths. We keep the same name. Now subtraction's a lot more difficult. You'll look at this and think, well, 2 is smaller than 6, but then you realize the place values are off. 0.02 is a lot larger than 0.006. We can't subtract these. This would end up being a negative number. If you think of what we talked about with integers, 0.006 goes that way, negative 0.002 is longer and goes the other direction. We end up as a negative number. So we'd end up having to switch that and do the 0.02 minus the 0.006 and filling in the missing zeros. If it's the other way around, however, 0.08 minus 0.003, lining up that decimal point, we just have to fill in a missing zero and borrow. So really for subtraction with decimals, there is not a real good, quick estimate that you can do when you're subtracting decimals. Multiplying and dividing, however, we can. Let's look at multiplying. And I'm going to equate this to rounded whole numbers. If I had 300 times 20, I took the 3 times 2 and I got 6, and then I counted. I have 1, 2 zeros there, and I have 1 0 there. 2 plus 1 is 3. I have 3 zeros in my answer. If I had 4,000 times 600, same type of thing. 4 times 6 is 24. I have 1, 2, 3 zeros here, 1, 2 zeros there. 3 plus 2 gives me 5 zeros in my answer. Well, the same is true for decimals. When we're multiplying decimals, we're not counting the zeros, we're counting the decimal places. 0.004 times 0.02. 4 times 2 is 8. This is 3 decimal places. This is 2 decimal places. Our answer has to have 3 plus 2 or 5 decimal places. 1, 2, 3, 4, 5. There's my decimal point. Division. If I have something like 800,000 divided by 400. Remember our shortcut, you divide 8 divided by 4 is 2. This has 4 zeros. This has 2 zeros. We're subtracting. 4 minus 2 is 2 zeros in my answer. If I have 60,000 divided by 2,000, same thing. 6 divided by 2 is 3. Here I have 4 zeros. Here I have 3 zeros. Well, 4 minus 3 is 1. I only have 1 zero in my answer. When I was dividing, I subtract the number of zeros.
Shouldn't there be 5 zeros for the 800,000?
You're right, that is 5. 5 minus 2, that should be 3. Good catch. Thank you. Good thing we're almost done. I believe that's strike 3 on me for the day. So if we have something dividing with the decimals rather than with the zeros, 0.0008 or 0.0008 divided by 0.04, well, 8 divided by 4 is 2. This is 4 decimal places minus 2 decimal places. We need 2 decimal places in our answer. 4.00006 divided by 0.0002. 6 divided by 2 is 3. Well, this is 5 decimal places and 4 decimal places. 5 minus 4 is 1. That's just going to be 0.3. That's already our 1 decimal place. So the estimation is very similar to estimating with zeros in our whole numbers. So quiz 2, technically we would have completed it at the beginning of class today, before we started decimals. Quiz 2 is on fractions. Make sure, a couple of you have already submitted it in email. Please go back and resubmit it in Blackboard for me. So I have it in Blackboard. It's going to be so much easier to give feedback and to keep track of which quiz goes to which class that way. So if you could make sure you submit that in Blackboard. I must give you to by noon tomorrow. We'll just say noon Tuesday. So get that submitted. There is going to be another quiz tomorrow because of the 2-hour block today. We finished up enough. There is another quiz here. I apologize for stacking them up. There might actually be quiz 4 by the end of the week. We just moved so fast on this initial material. If you need to slow down, let me know. I'm more than happy to slow down for you and take some time and push things back. But we will be hitting quiz 3 tomorrow already. Homework for today. I have a little book. It is units 11, 12, 13, and 14. Again, the odd numbered problems. Is there anybody that still does not have the little book?
Yeah.
Okay, there are a couple of you. Okay. This does still match up, so I should still be able to give you homework out of the big book here. Do you have it coming? Is it going to be here soon, you know?
I would think so.
Okay. Let's see here. So out of the book, the big book, it's section 3.9 to 3.15. Three nine starts on page 124. Okay, so we are about 40 minutes early here, but I wanted to give you, we took your 10-minute break, and I wanted to give you 15 or 20 minutes to work on that quiz, and I owe you about 10 or 15 minutes worth of homework time. So if you guys want to work on homework, I'll stay on the network with you if you want. Otherwise, if you'd rather get going to work on the quiz, please feel free to go ahead and bug out and work on the quiz. So it's up to you. I won't force you to sit here and work over the network in front of me if you guys want to take up.
I just want to make a note. In the class this morning, he had down chapter 23 for 10-1.
Yep.
It's 9-1. It's due tomorrow.
Yes. Did I have that wrong?
No, it wasn't you, Mr. Hoff. It was in the word class.
Oh, gotcha.
At 9-1 is due tomorrow?
Chapter 23.
Okay.
It's due tomorrow on 9-1, not 10-1.
Oh, I got you. Well, that makes me sad.
I bet it did.
Hey, Davey, is the workbook required tomorrow? We have to fill out the workbook too?
Yep. I believe so.